All right, ladies and gentlemen, here is a good review for our quiz. Quiz 5 is going to be due Tuesday. I'll put it online tomorrow morning, Monday morning early, so you'll have all day Monday, all day Tuesday to work it. I'm going to give you 2 shots at it, so if you don't do well the first time, try it again. There's going to be 5 questions, and here's what they're going to look like. First of all, it says, consider the following function. Q of x equals 7 times the absolute value of x. Now here's where you're going to want to refer to something that I sent to you earlier. 2 sheets called the basic functions. 1, 2, 3, 4, 5, 6, 7, 8, 9 basic functions. All of our transformations will be on one of these basic functions. So the first thing it says is identify the general, that's the key word, the general shape of this function. That's the absolute value of x. So I go to my basic functions and look for the shape of absolute value of x. Aha, there it is. Absolute value of x is an upward pointing v. The negative of the absolute value of x would be a downward pointing v, but this guy is a positive absolute value of x. So it is the general shape is what I'm looking for. Hey, it's an upward pointing v. So you're going to choose the option that is an upward pointing v. I would have this handy. I would have this run off and have it handy for your exercises and your quiz and your test when that finally comes up. This is going to be very important. All right, so that's the first part, just the general shape. Hey, it's an upward pointing v. Secondly, it says find 2 points on the graph. This is the graph other than the origin, so I can't use 0 for my x. Now remember this, Q of x equals 7 absolute value of x is the same as, it's just a different form of, y equals 7 absolute value of x. So if you want to get a point x, y, I would choose this expression of the function. This is function notation. This is an equation in 2 variables. This is the one that's going to give me my points x and y. Now, one thing the question is going to tell you is your points have to fit within a 10 by 10 grid. In other words, you cannot have any x or y that's larger than 10. For instance, if I chose 2 for x, then Q of 2 is going to be, y would be 7 times the absolute value of 2. Absolute value of 2 is 2. 7 times 2 is 14. Uh-oh, that doesn't fit in a 10 by 10 grid. So that point would not be acceptable. So choose something easy and obvious. Choose 1 for your x. Absolute value of 1. So y is 7 times the absolute value of 1. Absolute value of 1 is 1. That's 7. So I got me a point, 1, 7. Hey, choose negative 1. 7 times the absolute value of negative 1. Let me think, the absolute value of negative 1 is still 1. 7 times 1 is 7. So if I pick negative 1 for x, my y still turns out to be 7. So here are my 2 points. Just make sure they fit within a 10 by 10 grid. All right, next, consider the piecewise function. Now, if you haven't looked at your video or if you haven't checked out your notes, you might not be familiar with a piecewise function. Best way to think of a piecewise function is it's a function that hasn't decided what it wants to be when it grows up. Or to think of it another way, it's a schizophrenic function. It's one thing at one time, it's another thing at another. This particular function is this if you choose an x that's less than 5. In other words, if you choose x is 2, this is how you're going to find out what f of x is. If you choose x of 0, which is also less than 5, this is how you're going to find out what f of x is. But it's also a different shape. If you choose an x that's greater than or equal to 8, this is how you're going to evaluate it. Pick an x that's 10. Hey, that's greater than or equal to 8. Then I substitute into this expression to find out what f of x is. So my first task is to find out, hey, which of these guys am I going to use to evaluate the function? Is it something less than 5? Or is it something greater than or equal to 8? So here we go. Evaluate the function at x is 3. Hey, 3 is less than 5, right? So this is the way I'm going to find out what f of 3 is. F of 3 is going to be negative 2 times 3 squared plus 3 minus 4. I'm using this expression to find what f of 3 is because 3 is less than 5. All right, no, I do my powers first. It's negative 2 times 9 plus 3 minus 4. It's negative 18 plus 3 minus 4. I'll do these two together. That's negative 18 minus 1. That's negative 19. So f of 3 is negative 19. And a lot of people don't realize this, but this is, in fact, a point on the graph of this function. Can you tell what the point is? It's x, y. It's 3, negative 19. But that's just a freebie. This is what you're looking for. What is f of 3? Why, it's negative 19. All right, let's find this guy. Evaluate the function at x equals 8. So which of these two descriptions describe what I do with this particular value of x? There it is. If x is greater than or equal to 8, this is the expression that I use. And my x is, in fact, in this category, greater than or equal to 8. So that's the expression of the function I will use to find out what f of 8 is. F of 8 is going to be everywhere there's an x, I'm going to put an 8. Negative 8 minus 6. Use your calculator if you need to. Negative 14. So f of 8 is negative 14. Now remember, that's also a point, right? Can you tell what point it is? 8, negative 14. All right, let's check this one out. Evaluate the function at x equals 6. All right, let's see. Is 6 less than 5? No. Is 6 greater than or equal to 8? No. 6 does not fit into either of these categories. So what I have to say about this particular expression, f of 6 is undefined. I do not have a y to go with this x. The function doesn't have any points where x is 6. So you either are going to find it with one part of the expression or the other, or you could actually have a point where the function is undefined. All right. Number 3, find the open intervals where the following function is increasing, decreasing, or constant. Now notice you have 3 options here. It can either be increasing, it can be decreasing, it can be constant. I gave you a picture of this in your notes. This is increasing, this is constant, this is decreasing. Constant means it's just the same y for every x. It's a straight line across. And increasing and decreasing are pretty obvious. Hey, if you're going from left to right and it's going uphill, that's increasing. Left to right and it's going downhill, that's decreasing. So this guy's going downhill, this guy's decreasing on this interval. And from here over, it is increasing. Notice what they ask you to do. Express those intervals in interval notation. Interval notation is the stuff with the parentheses and the brackets. So let's do the increasing part first. It's from -4, hey, it just keeps going on forever, right? -4 to infinity. So from -4 to positive infinity, this guy is increasing. Now here's a very important question. Is -4 part of the decreasing interval, or is it part of the increasing interval? If you're confused about that, there's a good reason you should be confused. This -4 is part of both of them. So here's my point. I do not use the point of transition where it stops decreasing and starts increasing. I do not use that in either of the intervals. So -4 is not included in this guy. -4 is not included in that guy. So when I'm talking increasing, it's not -4, it's everything to the right of -4. So I'm going to use a parenthesis to show -4 is not part of this increasing interval. So from -4 all the way to infinity. And I always use parentheses with infinity symbols, right? All right, decreasing, that's this guy right here. It's from -infinity all the way to -4. Again, nothing but parentheses for infinity symbols. So from -infinity all the way to -4. But wait a minute, -4 is a transition point, so I make sure I put parentheses with that also. So which interval is -4 part of? Neither one. It's not part of the decreasing. It's not part of the decreasing. It's not part of the increasing. All right, any constant interval? None. I don't know how they want you to say that, but there's not one. There's not a constant interval. There's nothing that just goes straight across. So when you're doing your interval notation, you're looking at the x-axis. I don't care how high it goes or how low something goes. You're looking at the x-axis. So from -infinity to -4, from -4 to positive infinity. All right. Find the greatest common factor. That's the last two problems, the GCF problems. Find the greatest common factor for these two. Find the greatest common factor for those three. Now, if you remember the notes, the fail-safe way of doing greatest common factor is just do the prime factorization. 25x y squared equals 25 is 5 times 5. That's easy enough. X is x. Y squared is y times y. Yeah, that's easy enough. 50y squared. 50 is 2 times 25, and 25 is 5 times 5. So there's my 50 in prime terms. Y squared is just y times y. Now, once I have them expressed in prime factors, I look for what they have in common. Hey, they each have a y. Hey, they each have another y. They each have a 5. They each have another 5. Anything else in common? No. So the greatest common factor has two 5s. Hey, if I got a pair of them, I include it. So it's got a 5 once, a 5 twice, a y once, a y twice. So my greatest common factor is 25y squared. almost foolproof. All right, let's do it with these 3. Same thing. I'm going to express each of these guys in prime factors. 10 is 2 times 5. X squared means 2 x's. Y is just a y. 2xy. Now, if you guys can look at these and come up with the greatest common factor, good for you. But I'm giving you a foolproof way of doing it if you have any question. 2xy is just 2 times x times y. 6x squared. 6 is 2 times 3. X squared is x times x. So I have broken down all of my terms into prime factors. And I see what not just common to 2 of them, but what is common to all 3. They all 3 have a 2. So that's going to be part of my greatest common factor. Do they all 3 have a 5? No. A 3? Do they all 3 have an x? They do. Looky there. They all 3 have an x. Do they all 3 have a y? They do not. So this is the only factors they have in common, a 2 and an x. So my greatest common factor is 2x. All right, that's as challenging as the quiz is going to be. It is going to be due Tuesday at the end of the day, so make sure you take care of that. And if I were you, I would have handy my basic functions, because you're going to have to identify the general shape of some function, and it's going to be one of these guys. So you're going to have to identify one of these shapes for your number 1 problem. All right, good luck to you.